This is a cuda program which is written to calculate the addition of two matrices. So let's see how we can add two matrices using this program by using cuda. So first of all, I have included these libraries. This CUDA runtime library and device launch parameter library is used for as CUDA libraries when we need to include them if we are writing a CUDA program. And this stdioh library is used in C programming. Here I have used this because I have taken input and output in this code so this is an standard input output library which is used in C, therefore I has included it. So next we'll see when writing a CUDA program we should write two code parts separately in each and every CUDA program. One is known as the host code and the other one is known as the device code. So the host code is written for the CPU and the device code is written for the GPU. So in this program also I have two code parts, host code and device code. I have included the host code in this add matrix method and I have included the device code in this add matrix method and I have included the host code inside this main method. So I have written this add matrix method for the GPU and this main method for the CPU. So the other thing is when we write a host code and a device code, how can the compiler differentiate these two codes? They should be that means they should be run in the GPU and they should be run in the CPU. For that purpose, to identify the device code, we use this global keyword. In here also I have used this global keyword. By using this global keyword, I have said that this code or this method should execute in the GPU. So we'll see we'll go inside this method, add matrix method. So I have taken a method known as add matrix and I have given three parameters inside this method. These three parameters are integer parameters, but the specialty is I have given pointers as the parameters. I have given three pointers as the parameters. These pointers point for the memory locations of the GPU. Next, I have taken three integer variables known as a, b and id, and for each and every variable I have assigned a value. So what is this value? For the a I have assigned a value known as block idx.x. So let's see what is this block idx.x mean. Here this block idx.x gives the respective block id which starts from 0. In my program I earlier also I said that I am going to calculate, I am going to take the addition of two matrices. So if when we talk about a matrix is nothing but it's a two-dimensional array. So because we are going to talk about a two-dimensional array, we need two dimensions, x and y. So that for that purpose I have declared two variables known as a and b to take the respective block IDs of these two-dimensional values of for the x dimension block IDs are taken starting from 0 to the variable a, and the block IDs of dimension y starting from 0 is taken to the variable b. Next, here in the id variable I have calculated value for the id by using the grid team.x value. I have taken that value and it multiplied it by the value of a and added it to the value of b. Likewise, I have calculated the value of the id value of g by adding the immediate value of E to the immediate value of F. So this is the code part which runs inside the GPU. Now we will see what happens in the CPU. So in the CPU or in the main method, I have first declared three two-dimensional arrays known as M, N and R. I have given their size as 2 and 3. That means the number of rows is 2 and the number of columns is 3. So the matrix is going to be a 2 by 3 matrix. So after that I have initialized three pointer variables known as Q, S and T. We'll see what we use it for when we go further. And next I have declared two integer variables known as I and j. Here these I and j integer variables I have taken for the use of these for loops. Here I have taken two for loops to take the values for the matrices. The matrices which are going to be added. For the first matrix and for the second matrix I have taken the user input. So for that purpose this I and j integers are taken, and here by this code, here I have done, the thing I have done is I have taken the user input for the matrix, first matrix and the second matrix which are going to be added together. Next, here this is a method called cuda malloc method. We'll see what is this cuda malloc method is used for. This cuda malloc says that this method is used to allocate memory from global memory on the GPU. So for those three pointers, I have said the Q, S and T, here the memory addresses of these three pointers are taken, and I have assigned memory location for these from the global memory on GPU for these three variables. And next, the thing I have done is I have copied this input which is taken from the CPU to the GPU by using the CUDA memcop from host to device. So here the M and Nth values which is taken from the user input from the CPU is sent to the GPU Q and S locations. So this is done through this code part. And next, what is this dim3 grid 32? What this means? This is here, as I said earlier, I am going to construct a two-dimensional array. For that purpose, I need a two-dimensional block. For declaring a two-dimensional block, CUDA has a data type known as dim3. So that is here why I have taken this dim3 data type for declare the a block. Here grid is the variable name I has given, and here I have given the block size. That means I have taken one block with 3 columns and 2 rows. That is what is saying here. Next, I am going to call to the kernel. Here in this part I am going to call to the kernel and say that I need this amount of space from the GPU. Here this value says that the number of blocks which is needed from the GPU, and this value says the number of threads per block in these blocks. So here I have taken the value of grid as the value for here. That means I need one block from the GPU which has 3 columns and 2 rows, and each block consists of one thread. This is what's saying from here. And next, these QST are the arguments which I have passed. So after that, the execution is done in the GPU, and next after the result or the output is calculated, Again, the CPU takes it back from the GPU to the memory of the to the CPU. So that is done in here by the CUDA memcopy device to host method. It takes the output from the GPU to the CPU. That means the teeth value. That means the calculation the teeth memory locations values are taken to the R two-dimensional array which I has declared in here. So after that, I have again used a printf and a for loop to print this output according to our necessity, and the turn 0 gives the in this method. So that is what this code says, and this is how by using CUDA we can add two matrices. Now we'll see whether this code is correct and whether the correct output we can take the correct output from here. For that, first I am going to compile this code and let's see whether it's working properly. Yes, it worked properly and we got the window. So we'll enter and see values for this first matrix. And for the second matrix also we'll enter some values and we'll see whether the correct output is coming. Yes, we can see the output of the true matrices as here we can see the output. So this code is running perfectly, and this is how we can run a CUDA program